Hello and welcome to this repair tutorial, and today we're going to look at a creek and the model number is CAS4040. Specifications: RMS power output is 30 watts per channel when you connect 8 ohm speakers, and on the rear you can have both switched and unswitched speaker terminals. Just to clarify what we mean, if they is unswitched, if you connect your headphones to it, then you'll continue to hear the audio through the speakers, and then if it's switched and you use those respective terminals, it simply means that when you plug in your headphones, then logically the audio will not be heard through your speakers. And then for input sensitivity, because you can connect a moving magnet type cartridge via a turntable, it's 2.5 millivolts at 47 kiloohms. And then for your other inputs, which is auxiliary, CD and tuner and tape, that's 250 millivolts. And then for your impedance, for the auxiliary input, it's 20 kiloohms. But then for tape and tuner, that changes to 47 kiloohms. As we mentioned, you can connect a set of headphones to it via the 1/4-inch jack socket on the front. And then the HP filter, which is seen on some of the earlier amplifiers, has been replaced. And now you have a mute attenuation button. And then you also can select mono mode. And then you also have individual bass, treble and balance controls. And then overall weight comes in at 4.4 kilograms. And a slimline amplifier. So in terms of height, you're looking at 60 millimeters, and then for your width 420, and then your depth is 185. Now, I've done a number of these repair tutorials and I often use the word classic British amplifier, which is true for these units, and you see them in different versions, this one being one of the earlier ones. Now, what was the issue when the amplifier came into the workshop? Well, it didn't power up, so there was no visual indication on the front, and the amplifier was powered up via the dim bulb tester, and I've sort of put a link to the video in the description. And the light bulb didn't light brightly, so it didn't indicate, for example, that the amplifier was drawing excess current, but equally so, it wasn't drawing any current at all. So the first thing to do, of course, is just to remove the wooden top cover and just do a visual inspection. And on this amplifier, internally you have 4 fuses. You have the speaker output protection fuses, which are time delay 2 amp. And then you also have 2 power supply secondary protection fuses, which again are T2 amp. But you also have a protection fuse which is on the rear of the amplifier. And what I'm showing you here is that power input protection fuse. Now, when you look at the glass fuse, and this is 20 millimeters by 5 millimeters OD, what you can see is that the fuse wire is vaporized. So when that happens, it is really confirming that the amplifier has drawn excess current. Now, because the other protection fuses hadn't failed, I'm really looking at the primary side of the power input circuit to understand, what is it that's drawing this excess current. So here what you see is an extract from the service schematic, and here there is no manual. This is a very, very early amplifier. But there are different versions of the circuit diagram, but this one does match exactly the layout of this amplifier. And what I'm highlighting here are a number of things. The first one with the red circle is the protection fuse. And of course that, as we mentioned, had vaporized, so excess current. But what I'm also showing you as well is the transformer. And then you can then see on the secondary side of the transformer, we have the bridge rectifier diodes, and there are 4 of them. But also in parallel are 10 nanofarad capacitors, and these are used for high frequency filtering to remove noise. Now, commonly when you see the input power protection fuse blown, it tends to indicate that you have shorted turns on the primary of the transformer. But before you sort of get into it and say, okay, I'm just going to remove the transformer, what you need to just verify is that you don't have an issue on the secondary side. And so here I've just do a resistance measurement check just on the rectifier diodes on the secondary side, and of course the capacitors are in parallel. And the reason why I do that is I've had previous repairs where one of the rectifier diodes is shorted, which again will blow the input power fuse. But here there was no issue with the rectification diodes. And then here what I'm showing you is the actual board. So there are the power supply protection fuses, and this is of course on the secondary side. And then what you also see now are the rectifier diodes and the and the capacitors, which are in parallel. So just do that resistance check to find out if they've got any issue. And then what I found was no issue with the rectifier diodes or the capacitors. So that really confirmed that there was an issue then with the toroidal transformer. And because you've got the dim bulb tester, you can quickly make a test. So you can power it up via the dim bulb, and what you found was that the bulb lit very, very brightly, so confirming that we had shorted turns. Now, with this amplifier, and if we look at the circuit schematic again, what you can see on the primary side is that it's, for the UK operation, is 0 to 30 volt, and the VA rating is 120 VA. But here it's indicating to you that the output voltage from the transformer is 44 volts AC. Now, this transformer was made by a company called Airlink Transformers, but 44 volts is quite common if, as I do and many other sort of repairers would have, a 0.22 transformer in stock. So it's very easy, and it's sort of indicating on here, this is probably the case, that they use two 22 volt output windings on the toroidal, and what they do is they just connect them in series, effectively giving you the 44 volt AC. So you don't have to go out and look specifically for a 44 volt AC transformer secondary. You can just use a 22-0-0-22. So what I now bring to your attention is the toroidal transformer inside of the amplifier. And what you can see here is that there's some discoloration on the plastic covering, but also as well I can see visually that some of the enamel on there has come away, and that's where the shorted turns are. And this is not uncommon. What you can find is just over time, or maybe the transformer starts to overheat, the enamel insulator, which is coating the copper wires, just breaks down, and then it then shorts a number of turns, which results then in more heat and then additional shorted turns, and then to the point where the amplifier protection fuse will then kick in. But of course it's doing its job. And then the next thing that you can see is really taking the front fascia off from the amplifier, and then to release it from its bottom chassis you also have to undo the two fixing screws, and these are Phillips type, just holding in place the switch mechanism. And then what you'll see is that there are plastic pillars supporting the amplifier board, and you just need to just press them in, and then you'll be able to lift up the circuit board. And then what I'm showing next is just the underneath of the board, just for your own information. And as you can see, it's very busy. There's a lot of interconnecting cables which have been soldered on. And as I said, this is a very, very early amplifier, so this is definitely hand built. There's no reference numbers on the circuit board, and if you're doing fault finding, you can sort of refer back to the schematic, but you just need to work your way around to identify which components are which then. And then the fitting of the new toroidal transformer, I'd say, is probably not the easiest thing in the world. And the reason why I say that, okay, releasing the top fixing bolt and the top plate, that's easy enough. But what's not so easy is wiring up the primary of the transformer, because one lead connects to the fuse, which is at the rear, and then one of the other wires, which is the neutral, connects it to one half of the power switch. Now, the original transformer didn't have insulating wires for the input-output voltage connections, and what I mean there is that you have these PVC colour-coded wires. What you found was that they just put sleeves over to colour code them, but it was actually the enamel wire, so they just scrape away a bit of the enamel and then they can solder it directly onto the circuit board and then onto the fuse and then onto the power switch. Because the cable length for the connection to the fuse and then also to the switch is so short, and then also what you have are boot sleeves, so it's very easy for one of the terminals of the fuse holder just to sort of break off and they become brittle. So what I've done for this amplifier is I did replace the fuse holder. It's a chassis mount type for two reasons. One was, yes, the terminal was extremely sort of flimsy, and I didn't want that to result in an issue further down the line. But also as well, where you put a terminal or a screwdriver in flat blade to remove the fuse, it was quite chewed up. So cosmetically, it's just better to just put a brand new fuse holder in there. And then the next thing that I'm bringing to your attention is the measurement of the secondary voltage. Now, on the service circuit schematic, what you can see is that it actually details that it should be approximately 62 volts. And here, with the amplifier powered up, and this isn't via the dim ball tester, so effectively direct from the main supply, you can see that it's measuring 61.5 volts, which is fine. That's as per the service schematic. And then the next thing, once that was done, I could do a quick operational check just to verify that the amplifier was working, which it was. There was no concerns. But you need also as well to clean the user controls. And I often put this in some of the earlier repair descriptions where there was no audio tutorial. So what you can see is the circuit board, and I've just sort of stood the amplifier up on its edge, and then I've got an arrow pointing to an access hole, which is for the potentiometer. Now, you commonly see these on older type potentiometers. The newer ones are more enclosed and they're like plastic encapsulated, but on the earlier ones where you had carbon tracks, there's always a port. So what you would do here is you would spray into there De-Oxit D5, and then I just take a bit of kitchen roll just underneath, because there's another hole the other side, and then I just rotate those potentiometers backwards and forwards multiple times, and that will then clean off any oxidization or residue or dirt and leave you then with, you know, smooth operation. Again, no crackling noise or intermittent loss of sound, and you do that for all of the potentiometers. And then the next thing that I'm highlighting is the bank of input selection switches, and again you have a hole on each one of those, and you can spray directly the contact or switch cleaner into there. And what you need to do then is just to operate the switches multiple times. Now, some of those switches are latching, i.e. momentary, and then some, of course, for the input, as you select one, then the mechanism will release the previous selection. And again, just spend a bit of time doing that. And then here what I'm highlighting is that the amplifier has its original Philips audio output transistors in circuit. And also as well, what I do is I just verify that the heatsink compound, which is between the mica washer and the black heatsink and the rear tab of the transistor, is good, i.e. it's not dried out. If it's dried out and almost like chalky or flaky, then you need to undo the fixing screws and then reapply some heatsink compound just to ensure that you get that good thermal transfer. What I'm showing you now from the top is the new toroidal transformer has been fitted. Also as well, the connections to the speakers are also present, so it's just going through an operational test. And then I also clean up the amplifier fascia and remove, you know, any sort of dirt or grease which has accumulated over the years. And as I've said many times, I am a fan of these Creek amplifiers, and they are still sought after. You know, people still seek them out and have them as part of their hi-fi system, and they are a pleasure to work on. I really do enjoy restoring these back, really to what it would have been like when it left the factory. And then here what you can see are the removed parts or removed failed parts. So there's the fuse holder chassis mount. You can just sort of make out the fuse, and then there's the air link transformer. Finally, here from the front, just showing you that the amplifier is in operation. And really that sort of brings us to the end of this repair tutorial. So hopefully you've learned something along the way. And if you have any questions or you need any kind of support, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any guidance or assistance that you may require. So until the next time, all the very best. Cheers and bye-bye.